Hi there, Year 8. This video here, we'll be looking at exercise 4H, volume and capacity, okay? So first thing is, part of the exercise is you need to learn how to convert between volume units. Capital ML is not milliliters, and notice the difference between these two. This is your milliliters, but then this is your mega, okay? So this is your megaliters. Now, for each one, what's nice is that it's actually easy to go through because you need 1,000 of these mils, 1,000 of these, so times 1,000 of these mils to make one of these liters here. And then you need 1,000 of these liters to make one of these kiloliters. Okay, and then same thing, you need 1,000 of these kiloliters to make one of these megaliters. And so when you want to go backwards in the chart, it would then be divide 1,000 for megaliters to kiloliters, divide 1,000 to go from kiloliters to liters, and then divide 1,000 liters to get back to milliliters, okay? Now, some common conversions that might be helpful for you in terms of milliliters is normally in liquid form versus a length measurement. What you might not realize is that 1 mil, okay, so 1 mil of liquid volume, so think of a little medicine cup, right? If you fill up 1 mil, that is equivalent to 1 cubic centimeter. And what that basically means is, you know those unit cubes back in primary school where you had like one of those cubes, so that's a unit cube, and then you have the tens cube, it's like that thing where it's like 10 of them, yeah? And then you got that hundreds one, like 10 by 10, yeah? So one of those unit cubes is actually 1 centimeter by 1 centimeter. So 1 centimeter by 1 centimeter by 1 centimeter. If you times all of that, that's 1 cubic centimeters. And that will house, if you had a container that was that small and you filled it up with water, that will equal to 1 milliliter. Cool fact, huh? Okay, so that's what 1 milliliter is equivalent to. It's one of those cubic unit cubes that you would have played around with in primary school. And so then 1 liter, since 1 liter is 1,000 of these mils, well, 1,000 liters is equal to 1,000 milliliters. And another nice fact is that when you have 1 kiloliter, which is actually just 1,000 of those liters, okay, so remember, 1,000 of these liters make 1 kiloliter, right? So 1,000 liter is actually equal to 1 cubic meter. And what that basically means is, if you can imagine like 1 meter on the ground, one length, and then 1 meter again. So 1 meter one way, 1 meter one way, and then 1 meter high. So think of a box. If you can think of a cardboard box that is 1 meter by 1 meter by 1 meter, that box there, if you filled it up with water, it would hold 1,000 liters. Okay, that's how you can picture it. All right, so you got the conversions there to help you sort of understand, and these two are useful because you're going from liquid form to measurement form or length form. Okay, so that's what the difference is between volume and capacity. When you say volume, it's the measure in length units, so hence cubic millimeters, cubic centimeters, cubic meters, for example, whereas capacity is actually the volume or the measure of liquid or gas that a container can hold. So like a can of Coke is 375 mils, right? Or like a bottle of milk could be 1 liter or 2 liters. So these are the ones that we normally work with in terms of capacity, all right? And so you could write kiloliters here as another example there, all right? So the formula for the volume has always been area times height. Technically, it's the cross-sectional area, but I'll just leave it there. But just think of it as area times height, okay? So maybe I'll just delete that so you don't get confused. But stick to area times height. That's how you find volume. And the logic to this is volume is always to do with 3D shapes, right? So a 2D shape would be something like this. That's a square. So the area of this section, you would say it is length times length, right? So that's the area of this square. Actually, I'll do a rectangle to make it easier for you to understand. Here's a 2D shape of a rectangle, right? This is width, this is length. So to find the area, you would say length times width. So that's 2D. So at the moment, it's 2D. But then if you want to make it 3D, so hence you find the volume, 3D, you would add on a third dimension. So here's your third dimension. You're adding on this third dimension and it makes it 3D. So that third dimension that you're adding on, this is the third dimension. And normally they call it the height, but really it's not the height. It's just the third dimension because this is your first dimension. This is your second dimension, hence why we call it 2D shape. By adding on a third dimension, it now becomes 3D shape. True? So volume was really just finding the area in 2D, and then you're multiplying it by the third dimension, which is how you get this entire box thing, and that becomes the volume. That's why it's area, which is 2D. That's the 2D dimension that you're actually working out normally. And then you're then multiplying it by the third dimension, which they normally call the height. So that's why in a triangular prism, as an example, if I just draw on a side, you see if I drew a triangle, the area of this we know is the area is equal to half times base times height, right? That's 2D. So at the moment, this is 2D shape. But then if you add in a third dimension, so if I added a third dimension like this, see that now becomes a triangular prism. So if you want to find the volume, volume will equal to the area, which we've got, the 2D, times by, well, what's the third dimension? This is the third dimension. So this is the third dimension. So normally they say it's area times the third dimension, which usually they call height. Okay, so that's why it's then whatever this is. So let's say the third dimension is 10 centimeters and the height was 1 centimeter and the base was 2 centimeters, right? Then you would have done find the area of the triangle and then you multiply it by 10. And the reason why you multiply it by 10 is that's the third dimension to make it a 3D shape. Okay, so in all these examples here, you'll find that that's what we do. We do find the area, which is the 2D shape first, and then you multiply by the third dimension. So let's have a look at this example here. Find the 2D shape. Now, there's a lot of 2D different shapes you can do. You can do the one on the bottom, you can do the one on the side, you can do the one on the top, but I like to do the one at the front. So here, this front is a 2D shape. You've got width and you got length. So the area of this front, so the area is 3 times 4, okay, this is the 2D component, that's 12, times by, now they call it height, but really it's the third dimension. Where's my third dimension? So hopefully you can see this is the third dimension because length was the first dimension, width was the second dimension, and then the third dimension is this part here, that's the 5. So that's your third dimensions there. You see that? That's your third, and that's what makes it a 3D shape. So that's why you times it by 5. And that gives you the area of 60 cubic meters. And that's the volume. All right, so I think I've just calculated that. But hopefully you understand that if I color code it, let's say pink was the width. So this is width, they're both the same. So that's the dimension. Then I add another dimension. Let's call it black now. So for length, this is length and this is length. Okay. And then I add in a third dimension. So here's in blue. So see the 3 colors, the blue. So I'm going to call that H for now. But you can see now if I draw out the third dimension, that's all the third dimensions. H is the third dimension. Length is still L. So this is L. So that's in black. And there's technically an L on the bottom as well, length. And then width. Well, we've got, this is width, this is width. So width, and don't forget you've got another H on the bottom. Can you see how I color coded it? There's only 3 colors to make this 3D shape. So W is like one of the dimensions, so you can call that the first dimension here. So then the length in black could be the second dimension, and your third dimension is height. So as long as you can find the area like of the 2D, and then you multiply by the third dimension, that's how you get the volume. And that's what I did. I just did length times width gives you the 2D area. That's the 2D area. Times by the third dimension, which they call height, third dimension. And so that's why I did 3 times 4 times by 5. And that's why I got 60 cubic meters. Okay, if you understood that idea, you can then start to understand why cylinder works the way it does and all the other formulas. So let's have a look at this one. Same idea. See, can you find the 2D area or 2D shape? And I can see this shape here, right there, that I'm coloring in now. This is a 2D shape. And this two-dimensional shape is actually a trapezium. Can you see how it's a trapezium there? That there's only one pair of parallel lines. It's a trapezium because I know this is 5 meters and this is 2 meters on the top and the height is 4 meters. So the area of this 2D shape, so 2D area is equal to, again, the formula for a trapezium. So this is a trapezium. If you've forgotten, it was half times A plus B. A and B are the two parallel lines times the vertical distance between the two. Yeah, so it's half times 2 plus 5, because those are the two parallel lines, times the vertical distance that separates them, which is the 90 degrees here. So that's 4 and not the 8. Okay, so times by 4, let's work it out. That's 2 plus 5 is 7. Instead of halving 7, we could do half of 4, which is 2. 2 times the 7, and that gives you 14 squared meters. Okay, so I now know the area of this 2D shape. So this is my 2D area. Where's my third dimension? Well, hopefully you can see the third dimension is me extending an extra line here, which makes it 3D. That's your third dimension. So the third dimension is clearly 8. So that's why when you answer this question here, it then becomes volume is equal to the area, which is 14 times, this is the trapezium, times by the third dimension, which is 8. That's the third dimension there. That's all 8 there. That's how much you elongate that area. So 14 times 8, I don't know what that is. Let's do 14 times 8, 112. So I now know the answer is 112 cubic meters, okay, for that volume there. Let's see for the next problem, and this is the last problem here. It says find the capacity, so that's a different word there. Remember, capacity is liquid form, so they want it in liters now. So all this time it was in length units, so m cubed, and then that was m cubed as well. So those are all in length units. Now we're looking at capacity. So for this question here, we know that for a container that is a rectangular prism 25 centimeters long, so we know that it's 25 centimeters long. We know it's 10 centimeters wide. Okay, so 10 centimeters wide, and it's 10 centimeters high. So 10 by 10. So it looks like they're all the same length there. So this is 25, and that's 10 centimeters. So volume, again, you got to just find the area of any shape. So I'm going to find the area of the front, just because I can. So the area of the front, so the front here is clearly a rectangle. So it's 25 by 10. And that gives me area. So this is the 2D area is equal to 25 times 10, which is 250. All right? So that's 250 squared centimeters. But then where's my third dimension if you want to do volume? Third dimension is here. This is what makes it a 3D shape. So this is the third dimension. Whereas all the other stuff is still the 2D components. See that? So the third dimension, which is also 10. So when you do the volume, we can now say the area, which is 250, times the third dimension, which is 10. That gives us 2,500 cubic centimeters. Okay. Now the goal is to write that not in cubic centimeters. Remember, they want it in liters. Now we know that one of the conversions back in our notes, remember, 1 cubic centimeter is equivalent to 1 mil, right? So since I've got 2,500 cubic centimeters, this is equivalent to 2,500 mils. So I'm going to write here, note, 1 mil is equal to 1 cubic centimeter. Okay? So now that you know that, then from here to here, we want to convert mils to liters. Look at your flowchart again. How do you convert milliliters to liters? And we know that milliliters to liters was, wait, did I do that chart wrong? Let me just have a look again. I did do the chart wrong. Whoops, my bad. Sorry guys, can you guys fix this one? Actually, it's actually the other way. It should have been 1 liter is equivalent to 1,000 of those mils, whereas once you're in mils, then you got to divide it by 1,000. So if you had 1,000 mils, that's equivalent to 1 of those liters. So hence you had to divide. So my bad. This should be it. Divide 1,000. Divide 1,000. This is times 1,000 times 1,000. Okay. Yes. Ooh, that could be bad for this part of the video. That's all right. I'll just tell the class to be careful with that one for H. Ooh. All right. Okay. Then let's now go back down here. So converting milliliters to, so convert milliliters to liters. Now to convert milliliters to liters, we know 2,500 mils is equivalent to how many liters? Well, we know we need to divide by 1,000. And that's 2.5 liters. And that's my answer. 2.5 liters is how much capacity this rectangular prism can hold. Okay, and I'll stop the video there.